Hello, class. So yesterday, I kind of hinted at the idea of an imaginary number. Remember on some of the problems when we were factoring by grouping, we ended up with a negative under a square root. Well, if you remember from last year, that's where imaginary numbers come into play. And complex numbers have to do with imaginary numbers. So today we're talking about imaginary numbers and complex numbers. So first, let's start off with the definition. An imaginary number is any number with I. So an example would be like 4i. And a complex number is any number with both a real component and an imaginary component. When I say component, I mean terms. So, for instance, this 3 plus 2i is a complex number because 3 is a real number and 2i is an imaginary number. So let's then talk about what I equals. Well, I is technically equal to the square root of negative 1. So anytime we have a negative in a square root, it equals some sort of imaginary number, some I value. So for instance, say if we had something like square root of negative 9, this is how we would do it. We would think, okay, well, what is the square root of positive 9? And the square root of positive 9 is plus or minus 3. But because there's a negative, we need to incorporate the I. So the square root of negative 9 is plus or minus 3i. Just like that. Simple as that. What if we had something like the square root of negative 100? Well, the square root of positive 100 is 10, or plus or minus 10. Because there's that negative, we need to add the I, so it's plus or minus 10i. Just one more example to cement this idea. Square root of negative 49, we have to think, what is the square root of positive 49? 7. Because there's a negative, it's going to become 7i. So I think y'all are starting to get the picture. Okay, so let's then talk about multiplicities of I. So I mean multiple i's being multiplied to itself. So let's start off with this. I is equal to I. That's a statement that is true, right? Anything is always equal to itself. But what if we square I? And I claim here that I squared is equal to negative 1. Well, let's think about this. Let's see, what color should I use? I'll use this. Okay. I don't know the names of my colors. Okay. So I is I squared I claim to be negative 1. Let's see here. Well, I know is the square root of negative 1. So I squared is really I times I, isn't it? And if I is equal to the square root of negative 1, I can replace it as the square root of negative 1 times the square root of negative 1. Which, what is the square root times the square root of itself? It's just itself. So the square root of negative 1 times square root of negative 1 is negative 1. Then I claim that I cubed is negative I. Well, let's think about this. I cubed is really I times I times I. I squared, by the way, is a pirate's favorite imaginary number because it's equal to I. Okay, that was stupid. All right. So I cubed is equal to I times I times I, which we know I squared is equal to negative 1. So I can say that this is equal to negative 1, this portion. So I could say negative 1 times I, and well, 1 times anything is just itself, but there's that negative, so this is how we get negative I. I then claim that I to the 4th is positive 1. Well, let's think about this. So I to the 4th is I times I times I times I. And I know that I squared is equal to negative 1. So I can say that this is negative 1 and this is negative 1. So really, it's negative 1 times negative 1, which is positive 1. And then notice what I claim here. I claim that I to the 5th is I again, so it loops back around. I to the 6th is -1 again, and then I to the 7th is -I, and I to the 8th is +1. Notice how it repeats itself, and that number will repeat itself forever. For instance, I to the 9th, we would just have to go back up and count 9. But let's see why I to the 5th is I. So I to the 5th, I times I, that's a lot of dots, I times I times I. So I know that these two equal -1 times I, so it's, well, and I know that these two equal +1, so 1 times I is just I, and it loops back around. So for instance, say if I want to find what is I of what is I of 15? Well, I will just count 1, 2, 3, 4, 5, 6, 7, 8, and since it repeats, I can count 9, 10, 11, 12, 13, 14, 15. So I to this 15th is the same as I to the 7th, which is equal to -I. And you can go on forever. If you want to, you can say, what is I of 10,000? Which off the top of my head, I don't know. But you have a 25% chance of guessing it right, because it's going to be either I, -1, -I, or +1. So let's get some practice doing that. So simplify it. I'm going to use this chart as reference. So I cubed, let's see, the first squared third, I cubed is really equal to -I. I to the 10th, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I to the 10th is really equal to I squared, which is equal to -1. And then I to the 14th, again, we just count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So I to the 14th is the same as I to the 6th, which is equal to -1. So that's how you do it. That's how we simplify multiplicities of I. Just use this chart. All right. Let's go on to another concept, simplifying square roots of negatives. So let's recall this idea that I is equal to square root of -1. So here we're asked to simplify multiple square roots of negatives that are multiplied by itself. So let's see here. Square root of -9 is going to be plus or minus 3i, right? I'm going to just put the plus or minus out front. We're not going to think about it just yet, okay? We'll tack it on at the end. But just know it's there. So the square root of -9 is 3i times the square root of -1. Well, the square root of -1 is just I, so it's times I. And i's work just like variables do. If we have an x times an x, it's going to be x squared. Well, I times I is going to be I squared. So, here's plus or minus 3i squared. Let's talk about something a little more challenging. What about the square root of -49 times the square root of -100? I know it might not look like a -100. I kind of forgot the negative, so I put it there afterwards. But that's square root of -100. So let's talk about the square root of -49. Well, that's going to be, and again, we just have plus or minus out front somewhere. Square root of -49 is going to be 7i times the square root of -100 is 10i. Well, let's multiply the numbers together and then multiply the i's together. So 7 times 10 is 70. I times I is I squared. Now, I've done 2 of these so far. And hopefully, maybe, I don't know, hopefully you guys maybe notice something, and that is, can we continue to simplify I squared? And that is true. We can simplify I squared. Because we know I squared is equal to negative 1. So how about we simplify further and replace I squared with negative 1? So let's go back to this one. This is going to be plus or minus 3 times negative 1. Well, 3 times negative 1 is going to be negative 3, but since we're taking account of both positive and negative anyway, does it make sense that our answer is just plus or minus 3? I hope you guys can see what happened to that negative 1. Really, plus or minus negative 3, right? Plus or minus negative 3. But since we're accounting for both a plus or minus, isn't it the same thing as just saying plus or minus 3? Yeah, it is. So let's apply that logic to this one now. And then we'll finally finish up doing this one with that logic. So we will, plus or minus, we will substitute negative 1 for I squared. And then let's see, plus or minus, this just becomes 70, or technically negative 70. But because we have the plus or minus, it's the same thing as just plus or minus 70. So this is really interesting. Notice how this happens. If we multiply two i's together, we are multiplying two imaginary numbers together, but we get back a real number, or a number that's not imaginary. It's interesting how that works through multiplication. So let's talk about this last example here. Square root of negative 64 times square root of negative 25. So I'm going to just write my plus or minus out front here so I don't forget. And then the square root of negative 64 is going to be 8i. Because the square root of 64 is 8. Square root of that negative is I. Times square root of negative 25 is 5i. So let's multiply these together now. 8 times 5 is 40. I times I is I squared. Don't forget my plus or minus out front. Let's substitute negative 1 for I squared, which is technically square root of negative 40. But since we're talking about both plus and minus, we can just say plus or minus 40. And that's it. So that's how we simplify rational numbers, or not rational numbers, square root of negative radical values. Let's go on to complex numbers. So we talked about imaginary numbers, and we'll finish off with complex numbers. So remember, complex numbers are numbers that have both a real component and an imaginary component. So today we're going to be adding them, subtracting them, and multiplying them. If z is equal to this, w is equal to this, find z plus w, that's just adding. This is subtracting. This is multiplying. So we've actually done this before, not with imaginary numbers, but with x's, right? 3x plus 2, and then another one would be like 4x minus 1, and then we'd have to add them together, subtract them, and multiply. Same exact concept. The only thing that is different is we have to remember that I squared is equal to negative 1, and that's going to come into play when we multiply them together. So let's talk about addition first. When we are adding, we just combine like terms, if you recall doing that. So we have 3 plus 2i plus 4 minus I. And like terms, well, these are the real numbers are like terms, and the imaginary numbers are like terms. So 3 plus 4 is 7. 2i minus I is 1i, because the i's are like terms as well. So the sum is just 7 plus I. Now let's talk about subtraction. So if you recall, when we were subtracting binomials, there was one extra step, and that was we had to distribute a negative, and maybe this will jog your memory. So it's z minus w, so I'm going to write z first, so 3 plus 2i, minus, and then I'm going to write my w in parentheses. Hopefully this is looking familiar. And we need to distribute that negative to both terms in the second complex number. That's very important. So, and then we'll combine like terms. So 3, let's rewrite it. 3 plus 2i. Negative times 4 is negative 4. Negative times negative I is positive I. And that did the subtraction for us, so now we can combine like terms. So we have 3 minus 4 now, and that's going to be negative 1. And then 2i plus I is going to be plus 3i. And that is the difference of z and w. Really quick, I just want to notice or point out, hopefully you've noticed that when we're writing complex numbers, the real portion goes first and the imaginary part goes second. That's just how it's, that's just standard notation for it, or standard practice, I suppose. Okay, so let's talk about multiplication now. So multiplication, we're going to multiply these, so we're going to be foiling these just as we foiled binomials. So I'm going to say, let's say we have 3 plus 2i times 4 minus I. So remember foiling, we're going to multiply this first. Oh, let me use green. I don't know why. This first term to both the terms in the second factor, and then we're going to multiply the second term to both of the terms in the second factor. So 3 times 4 is 12. 3 times negative I is negative 3i. Then 2i times 4 is 8i. And then 2i times negative I is going to be negative 2i squared. And we have to remember the I squared because it's I times an I, just like an X times an X is an X squared. So now you'll notice that we have like terms here, so we can go ahead and combine like terms. Hopefully this process for multiplication is very familiar because so far it's exactly how it is when multiplying binomials, which we've done. So it's going to be 12, negative 3i plus 8i is plus 5i minus 2i squared. And with the polynomials, we'd say, okay, we're done. We'd have a square term, we'd have an x term, and then we'd just have our constant. But we can go a step further here. Notice that I squared is equal to negative 1, so I can go ahead and substitute negative 1 for this I squared. So I could have 12 plus 5i minus 2 times negative 1. Well, that's just going to change the sign because it's times negative 1, so negative 2 times negative 1 is going to become positive 2. And then lastly, that imaginary number, or the imaginary squared, became a real number again, so we can combine the two real numbers. 12 plus 2 is 14, plus 5i. So that is the product of z and w. So let's go over one more example, and then we'll call it a day as far as the lesson goes. So now we have z is equal to 5 minus 3i, and w is equal to 2 plus 4i. So find z plus w. Okay. So this one, remember, we just combined like terms. So I'm going to write it out, 5 minus 3i plus 2 plus 4i. So we're combined like terms. 5 plus 2 is 7. Negative 3i plus 4i is plus 1i, or just plus I. So that's the sum. All right, going on to the difference, z minus w. I'm going to write z first and then subtract w from it. So 5 minus 3i minus, and then remember we need the parentheses because we need to distribute this negative, 2 plus 4i. We're going to distribute the negative to both terms. Very important you do it to both terms. When we were subtracting binomials, this was the biggest mistake that I saw. Y'all do. So let's see. 5 minus 3i. Negative times 2 is negative 2. Negative times 4i is negative 4i. And then we can just combine like terms. So we have two real numbers here. 5 and negative 2, which is going to give us 3. And negative 3i minus 4i is negative 7i. You might be wondering, well, we're subtracting these. Doesn't I squared? No. Remember when we were adding or subtracting, the variable stays the same? It's only multiplication that the I goes to square. Or that variables or whatever we were dealing with goes to square. I is technically not a variable, but it acts like one sometimes. So now find z plus w, or sorry, z times w. So now we're going to find the product of these two. So this is where we're going to multiply. So 5 minus 3i times 2 plus 4i. And we're going to FOIL. So we're going to multiply the 5 to both the terms in the second factor, and we're going to multiply negative 3i to both the terms in the second factor. So 5 times 2 is 10. 5 times 4i is 20i. Then negative 3i times 2, that's going to be negative 6i. And then negative 3i times 4i, that's going to be negative 12i squared. Remember, it's going to be squared because we have I times I. So now we can combine like terms, make our life a little easier. 20i minus 6i is going to be 14i, so 10 plus 14i minus 12i squared. And then remember, I squared is equal to negative 1, so we can go ahead and plug in negative 1. So 10 plus 14i minus 12 times negative 1. What the negative 1 is, it just changes the sign. So if you become fluent in this enough, you can just say, okay, drop the I squared, change the sign. Because that's eventually what's going to happen. But only if you feel comfortable doing that. So now we have 10 plus 14i. Negative 12 times negative 1 is positive 12. See what I mean? And then finally we have two like terms yet again. We have 10 and 12, so that's going to be 22 plus 14i. And that's it. There we have it. That is adding, subtracting, and multiplying complex numbers. So get started on the worksheet. Let me know if you have any questions, and have a good day.